I'm going to tell you a few things about getting Node.js application that you probably already wrote or you're at least writing to production. And this is going to apply to most of what you can write in Node.js. Some of the examples are going to assume you're writing something that responds to HTTP requests, but this is actually easily scalable towards WebSockets or any communication means applicable. And how am I able to tell you that? So this presentation is mostly a result of a few years of mistakes I made and learned from, or some things that we created in a team and it turned out good, which is less and less surprising every time you do it. So let's get it started. Well, you're writing an app, right? So I'm going to assume you're writing it in Express. I'm going to assume you are responding to some requests. And this is a basic app that everyone understands, right? So as I said, it applies to everything. And if you want to go to production, this is not enough. So first of all, you need to run your server. And just typing node space app.js on your remote machine is not going to cut it. You need to make sure that if your app dies, something can bring it up. So there are tools like Forever and Cluster, which are pretty old, and if you can use them to make your app work well and to manage when it works, someone else could. And they probably did it a few years ago. That's why I recommend PM2, which is much more. It's a whole process manager for your apps in production. It's written in Node for Node. You can just take it and run it. It's going to let you switch to new versions of your app without dropping connections. It has all the fancy features you could ever want. And this is how you use it. You just SSH to a machine. This is an actual SSH session I made to our servers at Ignite to list our apps on staging for you. Some of them are not yet in production. So we have 3 of them in production currently. Some of them are inside tools, so they will get to production in a different form. There's plenty of things that you can do with PM2. And after you have your process running, you probably want to know how is it doing. So first of all, you need to know a few things about the system around it. You need to monitor the memory, the CPU utilization, just the basic stuff you probably know already. You also need to check if the app is responding at all, and we're going to get back to this. So if you're using some basic monitoring, don't look for fancy tools unless you're a startup, which, well, you have to use the chance to get all the fancy tools you can. But if your company has an existing infrastructure and it has people looking at monitoring of other apps, even if you don't like the monitoring solution they use, even if it's Nagios with some SSH scripts and you're way past it, take it, use it, because bad monitoring with people looking at it is way better than perfect monitoring with you looking at it from 9 to 5 on weekdays. Okay, so before you actually go to production, you need to work on your app some. So here are some good practices that I chose from multiple of practices that we stumbled upon during building our apps. First of all, and I can't stress this enough, if you're writing something in Node, you want it to be stateless. This is what Node is for. So you can take multiple copies of your apps, run it across multiple cores, across multiple servers in different locations, and then randomly send every request from the user to a different machine, and it still works. How you do it? You don't store anything in memory inside the app for longer than the time to handle one HTTP request. As simple as that. So how do I do sessions? How do I do storage? It's all external. So you put sessions in Redis, you put anything in Redis. If you actually need to store something for the time being, whatever it is, put it in Redis, query it back whenever your request needs it. Redis is almost as fast as just taking it from the memory in your app, really. Okay, second thing most of you probably know, you need to do everything asynchronously. So at least start with promises. Everything in your app is a promise. If you are not reactive enough to use RxJS or anything and go throughout the whole app, starting from the DB, all reactive. If you want to have some imperative code, that's okay. Make sure it's asynchronous. So now, how many of you are actually aware that you don't have to use JSON parse, you can use an asynchronous JSON parser? Okay, not much. So yeah, there is such thing. You can parse JSON asynchronously, so if someone sends you 5 megabytes of JSON, all other clients will not have to wait till you parse it, which is a few seconds, but they will still get handled because you outsource the parsing to this crazy library that can do it line by line and then concat everything in a very smart way. This is awesome. You can use a stream version, you can use a asynchronous version. This is what you should do if you're getting JSON from outside of your app and database. Okay, second question. From those 3 of you, I guess, who said you know that you can parse JSON asynchronously, how many of you still use JSON parse in practice? Yeah, so the problem is you are always tempted to just use JSON parse. So just make sure you look at your app after you've written a big chunk of it and decide in which places it's actually not safe to parse JSON synchronously, because it's the first denial of service that's going to happen is JSON parsing. And if I didn't say JSON parsing enough, if you're using microservices, there's this company, I forgot its name, but they discovered that over half of their computing power in production is spent parsing JSON, because they had over 100 of microservices, which would send JSON between them. So they had to switch to some binary version. So take this into account as well. JSON parsing can be a half of your CPU power in production. It happens. And now the crazy slide. So even though you're in JavaScript, you sometimes need to make sure that something is structured the way you expect it. So you can go all in and use TypeScript, which I would actually recommend nowadays. TypeScript is a very good language, and you probably should start looking into switching to that. But if you already have an app or you don't feel like, there's tools that can help you. What you need to do is the objects that you're using throughout the whole app and you're sending from one function to the other, if they come from the database or from some user input, you should wrap them in something that can check if your fields are actually there. So with TypeScript, if you forget to put something in a field or you try to use a field that isn't there, you will get an error when you write the code. With good old JavaScript, you will know that you forgot about some field when a user sends you a screenshot with the text undefined. We want to be at least somewhere in the middle. So we're using a tiny tool that I called Strongly Typed. I wrote it myself because the competition was kind of uncomfortable to use, just because of that, and some didn't have tests. So you just define the shape of the object, and next time you deploy your app, you will get the error as soon as the object gets malformed, which is very comfortable because instead of getting input and saving it, you will throw an error to the user immediately and get your feedback. But yeah, consider TypeScript. So the last thing about the app itself is your dependencies. Some people already know that, but whenever you require something, it becomes your responsibility. It's not that you can download half of the NPM and figure out a way to bundle it all together without writing your own code, and you can sell it, and then it's someone else's responsibility to fix bugs. No, it's your responsibility because you made the app. So whenever you're writing something and you see this cool little thing you could download from NPM and use, instead of writing 3 lines, what's the point? You are still responsible for the code and you didn't even read it. So instead of doing that, consider if this module you're trying to use is even maintained. If it's not maintained, it's better to write a whole module yourself. And this is from practice. This is something that actually bit me before. Also, you are responsible for the security of your application. And it used to be a huge problem. Nowadays, it's just a matter of running one tool every once in a while. So there's Node Security Project, which is an open spin-off of RequireSafe. They're actually managing to go through the most popular things on NPM and check their security. And then you just run one command. They will scan all your dependencies and then let you know if any of them is susceptible to attacks. Then you can replace it or remove it, or decide that it was one of your dev dependencies and you don't care. Because, yeah, they scan everything to make you more safe. OK. And now the app is kind of ready for production. So what do we do next? We go to production, and then we see that, well, the app is working, but the clients are not happy. What now? Well, you need to have good logs. And if you remember one thing from this whole presentation, this is it. If you have a server that is supposed to handle more than one client, and it's written asynchronously, and you have logs all over the place, you need to make sure that you can figure out which logs are actually coming from which requests. Kind of trivial thing, right? And you always forget it in the beginning. So just make sure you generate a random number and you assign it to your logger instance and make sure that this logger instance lives as long as your request handling logic lives. And you just use this instance. And every log will have this thing, this ID in it. We even went as far to give them colors. So you can see that it starts with red, then there's gray, green, and red finishes, and there's green that finishes. And these are only the info level logs. I'm going to tell you more about log levels in a second, but if I gave you all the debug and trace logs, it wouldn't fit 10 slides from those requests. So you need to have a way to figure out which of the logs are from which request. OK, use log levels. This is less important, but you need to be able to decide which things are important for you to read right now and which are not. So the fatal and error log levels are pretty obvious to anyone. Let's skip it. Warn is kind of useless. It's just for logs that say, well, an error happened, but it didn't affect the client much, and we didn't care enough. OK, so this is an expected error. It's sometimes useful, especially if you have deprecated code, which will happen even 2 months after you wrote something. It just happens to deprecate when the requirements change. Then there's info, which is just the regular things in your application as you probably saw before. Request begins, request ends, something gets stored in a DB. Cool. So there's debug. Debug is the log level at which you start giving yourself information that you need to figure out what the app is actually doing in the business logic. And there's trace, which should contain all the data required to reproduce. So you log into the production monitoring thing, whatever you use, get the logs, read them, and you can copy-paste bits to your local host and run the same bit of code that failed on your local host to see what happens. This should work in most cases. Don't overuse it. You don't have to trace every variable you ever use. Okay, and you want to be able to change the log level while the app is running, so that daily you just run on the info or debug level, depending on how comfortable you feel about your app running in production. And then when something starts happening, you switch to trace and try to reproduce, instead of shutting down, changing the log level, bringing it back up, because then you will not reproduce anymore. And last thing about logs, if you log credentials, and you will probably log credentials accidentally, so don't assume you don't log credentials. You have to have a tool that will make sure your credentials, or actually your user's credentials, are not stored in your logs in plain text, because you use the whole bcrypt thing and you spend some CPU power on encrypting them, putting them in safe places, storing them in a DB outside of your server, and then you log them to a plain text file. That's not the point of what you did before. So make sure you also sanitize them in a way that they cannot be fetched back from your text logs. Now, monitoring is very important for a few basic items, like the request statuses and how much time things take. So you don't just want to monitor if your requests aren't failing in general, because then you will start getting one number for the whole app, which is not the resolution of data you want. So you need to monitor different functionalities on different levels. It is possible that your app is returning 404s to the users that just tried to open a file that didn't exist, but then if you see a spike in 404s, it probably means that you made a typo somewhere, and you need to look into the thing that is returning 404s. And now if you have a cumulative log of everything your app returned, you will get the information that number of 404s increased in one of your 25 API endpoints. That's useful. So make sure you have enough data and have some statistics about how long it took, even depending on the status code you returned. There are tools for that. I know there are tools for that. So you can just plug in something you pay for and get it done. But you can also do a very, very basic thing and just count the numbers, expose them somewhere. We'll get to it. And your good old monitoring that you already have in your company will handle this. OK. I hope this is obvious. You don't want to block your event loop. But you can't be sure. You're actually using a lot of dependencies, and maybe someone has a while true in there, and it sometimes blocks for a while. So you need to track it. There's a very cool module that TJ Holowaychik wrote while he was still with the Node community. It's called Blocked, and it's, I guess, 20 lines of code nowadays. That you just initiate your app and start this thing, and it will let you know whenever the loop, your main event loop, was blocked for more than 10 milliseconds, which should be very bad for you. Then you send it to some monitoring, and you make sure you investigate. And the investigate part is going to be a bit tricky, because it's hard to know that. There is a way to find things that block your event loop, but I will have to leave it for the very advanced part of this talk. For now, I can just give you a tool that I quickly made to just satisfy the promises use case. So if you have a promise and you pass a function to your then, this tool will let you spot which function that you passed to then was actually blocking, instead of just returning another promise and doing things asynchronously. OK, and there's a tool that integrates with Node for that. AppDynamics has a tool like that. I guess New Relic also. and I saw Keymetrics, which is the people from PM2. They also have some tools, but they differ in what they can do. Okay, and the last thing you absolutely need to look at is the increase in memory. It is possible to write an app that is not going to have memory leaks, but you still have to look at it. So in case you didn't know, Node.js has this regular JavaScript garbage collection. And JavaScript garbage collection has trouble when you have a lot of things that exist in memory and very few things to collect, because this is the bad case for JavaScript garbage collection. So because of that, a node process is limited to something around 1.5 gigabytes of memory. And if your app takes more, it's going to shut down. You have to be aware of that. So you need to watch your memory, even from the inside of the app, and probably look for a steady increase, because if your app starts at 50 megabytes, and then 2 weeks later it's 300 megabytes, you can be pretty sure if it's constantly growing, it's going to grow and grow until it crashes. This is a memory leak. You need to look for it. And how you do that? Debugging memory leaks is actually a very old topic. I had some presentations on meet.js Poznań about that over 2 years ago. There is a cool tutorial from 5 years ago. We all should be able to use that. There is a profiler you can use on your local or staging environment. I don't recommend running with profiler on production unless you're very desperate and very close to production. But in production, if you have a memory leak that only happens there, which probably is the rule, you first encounter memory leaks in production, you have to use the heap dump. This is something that writes all your current memory to a file that is readable to your regular Chrome developer tools. So you make a heap dump, then you wait a minute and you make another one. You load both of them and compare, and then in this huge mess of things that will not resemble anything to you, you have to find some names of your functions and variables that occur too many times and take too much space. Okay, that's fairly easy, right? Well, it's actually kind of hard to find them, so make sure you name your functions if they're doing anything useful. Okay, so how do you make the heap dump? You have to require a module called, surprise, surprise, heap dump. Now, if you read the documentation of it, they actually say that they do things to your node instance that you don't want to work with on a daily basis. So you probably want to only require that when you need it. This is why I suggest it's some kind of an endpoint that does it, or you have a way to trigger that from the outside. So if you say, I want to do the heap dump now, you require the heap dump only then, and then write the file with the dump. But don't publish this, because then you have a denial of service. Writing this heap dump file is actually very expensive. Well, obviously, you have to go through the memory and write it in a readable format. So this brings me to the maintenance endpoint. If your app is listening to some requests coming in with one server inside of Node, like an Express app, you also want to listen on some weird port only on localhost and hide it with some firewall rules, or don't forward traffic through your load balancer to this port. And there, you can have some very simple endpoints for your maintenance tasks. First of them is switching log levels. As I said, you just make simple requests from your local machine and you switch log levels. Easy. Then you can generate a heap dump. So the function that I just printed here is going to be invoked through this maintenance endpoint. Also, it can have a health check. So your good old monitoring can make a request to this maintenance endpoint. And this maintenance endpoint writes some data to your DB and then reads it back to make sure that your app is working and connected to the DB. Because it's quite easy, especially with promises, to make an app that is working and responding to HTTP, but then everything stops at the DB level when you lose connection. Okay. So it can also return some basic stats if you don't have better tools for it available. Now the heavy part. So there's a talk from a guy from Netflix, which is a must. If you want to do serious things with Node and you want to scale it and you want to handle big loads, a lot of people, you need to look at this talk and try to get yourself familiar with what the guy said, or even practice it for fun with your app before you get this heavy load, because it's easier to know how to do it instead of learn as you go, because when something bad happens, you're going to be stressed already. So he mentions flame graphs, which is the bit of complicated technique that you can use to profile your Node.js application. The drawback is to generate a flame graph with readable names of your actual functions. You need to use MDB, which is a tool that only works on Smart OS. So this is a product of Joyent. It comes from Solaris system. It's kind of nerdy. You have to run it in a VM to be able to generate something useful from your core dump that Node produced when it crashed. But don't worry, there's this post-mortem diagnostics working group, and they are actually working at finding a way to give MDB to anyone. Okay, what's next? Things I didn't put in that presentation because there's a time limit. So you can ask me questions about those, obviously. I hope we squeeze them in. You want to centralize error handling to have better control. You want to have feature toggles, which can be done in multiple different ways, and they can bite you badly. There's a lot of security issues we could talk about. There's a lot of techniques for not leaking memory, even though you need to store some things in memory. And there's plenty of cool things you can do to have no downtime when you redeploy your apps. So for all this and more, you can follow me, because all this is going to be a workshop soon. So once I create the workshop and figure out a way to open it to public, I will let you know. All you have to do is subscribe to this newsletter, or you can contact me directly if you don't like leaving your emails anywhere, and I will let you know when it's available. Okay, so thanks for listening, and you can still ask me questions. We have 2 minutes.
Hi, maybe it's not at all related to production, maybe rather to development applications. I mean, development state of application. But do you have an idea how to handle, let's say, Node modules repository in case that some of the modules may disappear in the future?
Okay.
Where to store this kind of, let's say, modules?
I know what I know what you mean, and there's this thing I didn't say out loud somewhere in here. Yeah, the first point here. When in doubt, npm shrink wrap. This is a way to make sure that your dependencies don't change, because some people still like breaking semantic versioning. So if you use any relaxed version definition in your package.json, you can end up with a different version of the library you're using on production than on your development server.
Exactly.
So when you're not sure about it, use npm shrink wrap. And if you're worried that the code is going to disappear entirely, well, then the only thing you can do is npm install once, generate npm shrink wrap, and then back up the whole thing into a separate repository. Do not commit your Node modules ever for any reason.
Question is where to put this. I mean, I don't want to store it
Yeah.
either in other repository. I know that, for example, for a backend, there are some software that you can use, yeah?
Yeah, and nowadays you can actually buy NPM support to get private NPM, and you can use that. But there are also projects that are described as a proxy to NPM, but you can actually use them to create your local NPM repository that you will going to progressively build up while you install things. And they do work, but nowadays when NPM is running from a CDN, everyone is dropping those because it's better to have stable source of modules for your builds and deployments than to have something that you have to maintain, and it's going to be down more often than the main NPM repository. Okay? And we're out of time. So if you want to ask more questions, I know it's probably a topic you want to talk about, in an actual exchange. I'm going to be out there. You can catch me also on the after party. So thanks for listening. This is all the experience I got from 2 years at Ignite. I hope you'll use it.